Welcome back. In this video, I'll show you how to design a BGA integrated circuit package in DEX, completely step by step. We'll be creating a standard BGA package using the built-in parametric tools, and along the way, I'll explain what the important settings actually do and how they affect your design. So let's get started. The first thing we need to do is create a new parametric part. Up on the Home ribbon, click the Parametric Part button. Once you click it, DEX opens a large library filled with configurable package types and device templates. To create our device, simply select the BGA package option. As soon as you do that, you'll notice several live preview windows on the right side of the dialog. These previews are incredibly useful because DEX updates them in real time while you configure the package. At the very top is the schematic symbol preview, so you can immediately see how the component will appear in your circuit schematic. Below that is the PCB footprint preview, sometimes called the land pattern. This shows the actual pad arrangement that will be placed onto your PCB layout. And at the bottom, DEX automatically generates a complete 3D model of the package. This is one of the really impressive features of DEX. You don't need to search online for third-party 3D models, and you don't have to build one manually in a separate CAD tool. Everything is generated automatically from the package parameters, which saves a huge amount of time during component creation. Now let's open the package. Double-click the BGA package, and DEX switches into the main editing workspace. In the center of the screen, you'll immediately see the PCB footprint editor. On the left side, there's a tab for the schematic symbol. And on the right side, another tab displaying the generated 3D model. To make the workflow even easier, go up to the Panels menu and select PCB and 3D. This splits the interface into two synchronized viewports. On the left, you can edit the PCB footprint, and on the right, you can rotate and inspect the 3D package model interactively. As you make changes to the package parameters, both views update together in real time, which makes it much easier to visualize the final component. If the Part Builder panel is not already visible, just open the Panels ribbon again and enable Part Builder. Now we can start customizing the BGA package itself. Over on the left side, you'll see the Parameters section. This area contains all the key settings that define the geometry and behavior of the package. At the top, you can configure the number of rows and columns. These values determine how many solder balls the BGA package contains. For example, increasing the number of rows and columns increases the total pin count of the device. Right below that is the pitch setting. Pitch is one of the most important dimensions in any BGA package because it defines the spacing between each solder ball. Smaller pitch values allow for more compact and higher density packages, but they also increase manufacturing complexity and PCB routing difficulty. So when selecting a pitch, you usually need to balance package density with manufacturability. You'll also see an option for adding fiducials. Fiducials are small alignment markers used during automated PCB assembly. Pick-and-place machines rely on these markers to precisely align components before they are soldered onto the board. Not every PCB requires local fiducials on a package footprint, but in high-precision or high-volume manufacturing environments, they can significantly improve placement accuracy. And that's essentially the complete workflow for creating and customizing a BGA package in DEX. What makes this process especially powerful is how quickly you can generate fully synchronized schematic symbols, PCB footprints, and 3D models from a single set of parameters. I definitely recommend experimenting with the different package settings yourself. Building parametric components like this is not only extremely useful for PCB design workflows, but it also helps you better understand package geometry, manufacturing tolerances, and real-world assembly constraints. Thanks for watching, and I'll see you in the next video.